Hello and welcome back. My name is Bilal Ahmed and you are watching Basics for You. From the previous two lectures, we know the difference between electrical and electronic engineering. We studied about the materials used for the electrical conduction using the conduction band theory. Then we learned about the construction of semiconductors by add dopants to an intrinsic semiconductor. Now we are fully prepared to make our first electronic component. Today we are going to make a diode, which is formed by joining two different extrinsic semiconductor together. We have already studied about semiconductors and their types. We know that extrinsic semiconductors are of two types, p-type and n-type. A diode is a point of contact of p-type and n-type semiconductor, so this is also called as p-n junction. This is the symbol of diode or p-n junction diode. The triangular part represents the P side of the diode, and vertical bar represents the N side. Till now we have constructed our diode, but we don't know how it works. So, let's jump inside this diode and understand its internal working. As we know that P side of the diode have holes as the majority charge carriers, while the N side have electrons as majority charge carriers. Inside the diode near the point of contact, the electrons from the N side diffuses into the P side of the diode. This causes the excess of electrons in the P side and deficiency in the N side. This create the positive and negative ions in the N side and P side of the diode respectively. These ions creates an electric field. Because of this, a potential barrier is created, known as depletion layer. This blocks the flow of majority charge carriers by acting as a resistance for them, but minority charges can pass through this barrier. In order to pass the current through this diode or p-n junction, the external applied voltage must be greater than the internal voltage barrier. The process of applying external voltage is called biasing. A diode can be biased in two ways. The two modes of biasing are known as forward biasing and reverse biasing. Let's understand about forward biasing. Before we move further, hit the subscribe button below to support this channel, also like and share this video. Thank you. Let's continue. In forward biasing, positive terminal, or high voltage terminal, is connected to the P side of the diode, and negative, or low voltage terminal, is connected to N side of the diode. In forward biasing, the width of the depletion layer starts decreasing as the voltage increase. This reduces the effect of internal voltage barrier. Smaller the depletion layer, higher will be current. For silicon, this voltage barrier is of 0.7 volts, and for germanium, it is 0.3 volt. In forward biasing, diode acts as a closed switch or short circuit. In case of reverse biasing, the external voltage is applied in reverse manner. This increases the width of the depletion layer. Therefore, blocks all the charge carriers to pass. As we continue increasing the voltage in reverse direction, there comes a critical point, where this depletion breaks down. This value of voltage is called as breakdown voltage. In case of reverse biasing, diode acts as open switch or open circuit. Therefore P side acts as positive side of the diode, so called as anode, whereas N side acts as negative side, so called as cathode. Now let's analyze the VI characteristics of the diode. This section, the forward biasing mode of the diode, you can see here that, as soon as the voltage level increases above the internal voltage barrier, there is a sudden change in the waveform. This represents the flow of current in forward biasing mode. This region represents the reverse biasing region. Here we need to give a large amount of voltage in reverse direction to turn it on or to break down the depletion layer. This point is called as breakdown point. Let's open our simulation software and use the diode is reverse and forward biasing mode. For the simulation part of the tutorial, we will be using Proteus software. If you don't have the software or don't know how to install it, relax, we have everything for. I have created a separate playlist for this, where you can install and also understand how to use the software and configure different components. So hurry up, go and get your software, the whole class is waiting. Good, let's continue. Now open the software, click on New Project, give a good name to it. Continue clicking on Next. Here is the workspace, where you can create your projects. Now go to the Library section, search for Diode, double-click on it to add in the component, search for cell, select it, yellow LED, resistor, push button. Now press Enter to leave this page. Connect battery, resistor, push button, diode, and LED in series and make the connect. Set the battery voltage level. Create another branch, change the polarity of the diode and add another switch on this branch. Now start the simulation. Now press the button alternatively. Here you will observe that, when you are pressing the button connect, the diode in the forward biased mode works as short circuit. Because of the current flows in the circuit and LED turn on. But, in the other branch, diode is connected in reverse manner. That is in reverse biasing mode, so blocking the current to pass. In this way you can add a diode to your circuit. This was all about diode. Thank you for watching.